Okay, let's give you guys some more practice. So now you're on the moon. Gravity on the moon is 1.622 meters per second squared. You're going to fire a cannonball at 90 meters per second at an angle of 54 degrees. The scarecrow is 400 meters away from the cannon. So work out if we're going to be able to hit our target here. Okay, so remember, on gravity on the moon is a lot weaker than on Earth. On Earth, we're 9.8. On Earth, on the moon, we are 1.622. So what it means is that on Earth, gravity is much stronger, so it's going to be able to pull the cannonball down a lot faster. On the moon, is the gravity is a lot weaker, so our cannonball is able to fly a lot further. Okay, just bear that in mind. So yeah, work out if we're able to hit our target when our target is 400 meters away. So press pause and have a go. Okay, so to work this out, at the moment, we're shooting at a diagonal in a diagonal direction. So break it up into the vertical and the horizontal components. So let's break this up. So this here will be 90 sine 54, and this would be 90 cos 54. Then jump to your velocity time graph. Your velocity time graph, velocity time. It should look something like this. This is our initial velocity. Well, don't forget, it's a bit hard to work it out when it's shooting in a diagonal direction. So we're going to break it up rather than working out the we're going to just visualize it like this. We're going to solve this problem. So to find out the total flight time, we are just going to look at this problem here. So we are shooting it vertically upwards. Okay. So the vertical velocity will be 900. Sorry, 90 sine 54, and we are trying to find out the total flight time here. But in order to find out the total flight time, we need to work out T max here. So we need to work out this point, the point at which the cannonball will be, the velocity at this point here will be 0. So work out T max. Once you've got this length here, you can just times it by 2, and that will give you the total flight time, which is when the cannonball will get to this point here, assuming we're going to hit it. So work out T max here. First, we need the equation for this line. So it will be V equals the initial vertical velocity, so which will be 90 sine 54, take away 1.622 t. So at this point here, the velocity will be 0. So put 0 into the V. So put 0 into the V. So this will be this 90 sine 54 minus 1.622 t. So now add this thing to both sides. Okay, so this would be 1.622 t equals 90 sine 54, and then yeah, solve t. So t equals 90 sine 54 over 1.622. Okay, so this point here is 90 sine 54 over 1.622. Okay, so now that we've got this length here, the total flight time will be times 2, because here's 1 and here's 2. Okay, so just times it by 2. So now this is our T max here, the time it takes to get to T max. So let's times it by 2 to get the total flight time. So flight here, flight equals this thing here times 2. So this will be 9. Would be 90. 90 sine 54 over 1.622, and then we're going to times it by 2 because if it takes this amount of time to get to T max, then this will be the same. So we times it by 2. So my point is that the time it takes to get from here to here will be the same as the time that it gets from here to here. Okay, so that we're timesing it by 2. So at the moment we've got this times this. So when we times it by 2, let's just times it to the top. Let's merge it with the 90. So that equals, we're just tidying up. That equals 180 sine 54 over 1.622. So this is our flight time, our total flight time. Now that we know our total flight time, now that we know it takes whatever we just worked out to do this, this here is the same as the total flight time. So now we need to imagine you and your dad sitting in a car, and and the car is doing 90 cos 54 meters per second. Now that we know the total flight time, we just need to get the flight time times the speed here, the horizontal speed. That will give us the range. Okay. Now, well, we know the total flight time, so let's times it with this here. So hang on. So range here, range. Oh, my pen's not working properly. Sorry. Range here equals. Well, this here is a total flight time. Okay. This is a total flight time. So let's get this and times it with the horizontal speed. So I'm going to get 180 sine 54 over 1.622, and then we're going to times it with the horizontal speed here. So it's now you and your dad sitting in a car. Okay. So I'm just going to times it with the horizontal speed. So that would be the horizontal speed is 90 cos 54. Okay. So now here we are timesing a fraction. So let's just multiply it to the top. So it will be number times with a number, and then merge these two together. Okay. So I'm just going to tidy up. So 90. I'm going to get 90 times this thing here, which will be, hang on, calculator. 180 times 90 equals 16 16200 sine 54 cos 54 over 1.622. So our range is given by this. Now just jump to a calculator and work this out. So it would be this. Hang on, my pen is not working properly. So here it would be 1.622 here. Let's work out this bit first. So this here will become, hang on, where's my calculator? Cos 54. So let's clear this. Cos 54. Where's cos 54? Cos 54 is 0.59. 0.59. I'm just going to round it off roughly. So now let's do this here. This will become sine 54 will be, hang on, clear. Sine 54 will be 0.81. 0.81. So remember, it's this times this, and then we've got to times by this. 1.62. No, it's not 1.622. It's 16200. Okay. So now hang on. So let's jump to my calculator here. Hang on. So it's just let's multiply these three together. So that will be calculator, clear. Where's clear? Clear's here. So it will be 16200 times 0.81 times 0.59 equals this, divided by 1.622 equals. So our overall answer would be, our overall answer would be 4773 meters. So well, you can do this bit on your calculator, okay? So whatever that number was, because I've already divided 1.622, and the overall answer would be this. So really, when you shoot a cannonball at 90 meters per second on the moon at 54 degrees, well, we have missed our target by miles, because what's happening is that hang on, what's happening is that this is our overall answer. Hang on, let me just do this here. Well, what's happening is that we are here, and the scarecrow is here. Okay. This is 400 here. 400. And well, if this is 400, 800 would be around here. Well, and so on. So 4, 4, 4, and so on. Well, this distance here, 4,773 meters, is miles over the other side, in this direction. So what we've done is we fired the cannonball, and it's gone something like this. We missed the target by miles. Okay. So the answer to this question is we didn't hit our target here. Okay.